Calculate the area the curve makes with the y-axis, given that y is equal to x minus 2 all cubed. So we need to recall that the area is equal to the integral of x dy in this case, since we're trying to calculate the area it makes with the y-axis. So this would be integral from y1 to y2 of x dy. So we need to make x the subject by taking the cube root of y first and then adding 2. That gives us cube root of y plus 2. Now we integrate from y1 to y2, but according to the graph, we don't know what y1 is. So we need to find when x is equal to 4. When x is equal to 4, the value for y would be 8. We are integrating from 0 to 8 of the function x with respect to y. If we replace the value for x into our question, we're going to have integral of y to the power 1/3 plus integral of 2 dy. This would be y to the power 4/3 divided by 4/3 plus 2y. And if you rearrange the fraction, you have 3/4 of y to the power 4/3 from 0 to 8. Substituting the limits in each of these, we would have 12 plus 16, which is equal to 28 squared units. Question 50. Find the volume of the solid formed when the curve R is rotated completely about the x-axis. Give your answer in pi and a natural log of 2. The curve has been given with the equation y equal to 6 square root x over 3x plus 1. And we are integrating from 0 to 1. So for us to find a volume of a solid of revolution, remember you need to do the integral from x1 to x2 of pi y squared dx with respect to x. So in this case, we would have integral from 0 to 1 of pi y squared will be 6 root x over 3x plus 1, all that squared. The square will cancel out since we're squaring, and we'll get 36x over 3x minus 1 plus 1 all squared. Taking out the constants, we have the integral of x over 3x plus 1 all that squared. We can work with the partial fractions for this and then focus on the numerator. So when x will be equal to negative 1/3, b will be equal to negative 1/3, coincidentally. And then when x is equal to 0, a plus negative 1/3 is equal to 0, and hence a is equal to 1/3. We would replace each of these values for a and b and integrate the values. So we need the integral of 1/3 3x plus 1 minus 1/3 3x plus 1 all squared. If we replace u with 3x plus 1 and we factor out the 1/3, this would give us 1/3 times the integral of 1 over u minus 1 over u squared. The first part will give us a natural log, while the second part will give us u to the power negative 2 plus 1 over negative 2 plus 1. So we would have 36 pi times 1/3 natural log of u minus u to the power minus 1 plus c. Now we can substitute back the value of u as 3x plus 1, and we get 12 pi natural log of ln 3x plus 1 over 3x plus 1. If we substitute the limits as 1 and 0 in there, we're going to have 12 pi plus ln of 3 times 1, etc., etc. And we'll substitute 0 as well, but then natural log of 1 would be 0. So the first part of the expression would be 12 pi times natural log of 4 plus 1/4 minus 12 pi times 1. Simplifying this, I'll factor out the 12 pi And we have natural log of 4 plus 1/4 minus 1, which is negative 3/4, right? And our final answer will be 12 pi times natural log of 4 minus 3/4. Okay, let's take a quick break. Why are pirates the best at calculus? Well, because a true pirate never forgets the sea. Here we have the diagram shows the curve y equals to x minus 2 all squared plus 1 with a minimum point at P. The point Q on the curve is such that the gradient of PQ is equal to 2. Find the area of the shaded region. Now, this question is a little hard because you need to figure out the equation of the straight line PQ. At least they've told us the gradient, so that's a good start. Recall that y is equal to x minus h all squared plus k, with the vertex being hk, right? So in this case, our vertex, which is a turning point, would just be 2, 1. Why is this important? We are going to use it to find the equation of our straight line. Okay, let's go ahead. Now recall that a straight line can be written as mx plus y equal to mx plus c. And in this case, m is 2, right? So if we have a point, we have the gradient, then we can find the c, the value of c, where it cuts the y-axis. So when x is 2, y is 1. Hence, we substitute these three values. We'll have 1 equal to 2 times 2 plus c, and hence c is minus 3. So then we get our equation of the straight line, y equal to 2x minus 3. Okay, now if these two lines intersect at P and Q, it means we can also find Q, because you know, for us to find the area of the shaded region, we need to find the integral, the definite integral from point P to point Q. We know just P, we also need to know Q. It will also intersect at point Q. So at that point, both of these equations, that is the straight line and the curve, are equal. So I'm just going to take my straight line equation and equate to the curve, just like so, and then I'm going to work it out. So we can do some expansion using the FOR method, bringing like terms together and then simplifying. We're going to have x squared minus 6x plus 8 equal to 0. Simplifying that by factoring, we'll have x equal to 2 and 4. Okay, perfect. It means that this would cut when P is 2 and Q is 4, and those are strictly the x values, right? So we can now integrate with respect to x. Let's go ahead. For us to integrate from 2 to 4, we must take the magnitude or the absolute value of the function, which I explained before. So we subtract the bottom function from the top function. The top function is the linear equation, which is 2x minus 3, and the bottom one is the curve itself. So expanding and subtracting, we would have 2x minus 3 minus x squared minus 4x plus 4 plus 1. And when we simplify this, we have negative x squared plus 6x minus 8. Okay, integrating this is actually easy. So we would have negative x cubed over 3 plus 6x squared over 2 minus 8x from 2 to 4. Okay, we'll substitute the values of 4 and 2, simplify them with the calculator, then subtract, and we should be able to get our answer at the end of the day. Now these fractions here, notice they have the same denominator. So if you pair the like terms, it'll be easier for you to work with. So I just color coded them for you to easily see what I'm talking about. This would give us 100 over 3 square units.